So today we're going to start on a new chapter, Harmon. All right. So this new chapter is called polynomials. I don't really use the textbook, but our textbook does this chapter in does this unit in 2 chapters. I'm doing it in 1. All right. So it's a longer chapter. It'll take us until spring break to finish it up. I'm hoping we've probably done the day before spring break. All right. So it is more stuff to know because it's a bigger chapter. I'll break the test off into 2 parts. One part will be adding and subtracting. That's the first half of the unit. The second half is multiplying and dividing. So I'm going to break it up into 2 chunks for you for the test. Right? But they sort of blend very nicely together. Right? That's what I'm doing as 1 unit. Right? So it'll take us right to a spring break. As in difficulty-wise, I think this is somewhere between the difficulty between the first unit. It's probably about the same or a little bit harder than the first unit, but easier than the second unit for most students. You may be a little bit different, each individual one, but I think difficulty-wise is somewhere in there. So today...
Wait, I have a question.
Yes?
Do these letters equal numbers or they just...
Oh, we'll talk about that right now. So today, it's going to be a short lesson, and all we're talking about is terminology. So this whole unit is called polynomials, and we're working with algebraic expressions. So before we can work with them, we need to know how to talk the language. Right? So today we're just going over different terms and what they mean and how to figure out what they are. All right? So algebra, right? And that's something that you started in grade 8. I'm hoping that you started it before you went to lockdown and started talking about COVID stuff, right? So algebra, we have expressions, and we use letters to represent unknown numbers, right? Those are the letters we see showing up. And those letters are just called variables, okay? They're just numbers that we don't know, or the numbers that change, right? Now, in this unit in particular, we're working on polynomials. Now, these are expressions that are made up of terms. How do you figure out how many terms an expression has? The terms are separated or connected by addition and subtraction symbols. Right? So I have an expression right below here, 3x squared minus 2x minus 7. I want you to circle the minus signs here, or the subtraction signs, right? Then I want you to put a line under the stuff in front of and in between those minus signs. Or in the future case, it might be plus signs. How many lines did you draw? 3. That's how many terms you have, right? The terms are separated by pluses and minuses. So use these as separators and just see how many terms are in between there, okay? Now, for example, if over here we have 6x squared, there's no plus or minus signs, it's just one thing. That is 1 term. And I should probably left this blank for you. Maybe in the future I'll change it. All right? Now, the next one, we have 1 minus sign. So you draw a line under this one and a line under this one. How many lines did we draw? 2, so there's 2 terms. All right? That's when we're going to do a quiz on Monday. That's as easy as it gets, right? The hardest part is not confusing it with something else. So I'm going to ask you, how many terms does it have? So here, subtraction, addition. I'm going to draw 1, 2, 3. So 3 terms. That's fine, right? And with polynomials, we usually only count up to 3. And everything else more than 3, we use generic terms for. And I'll talk about it in a second. So that one has a lot. 1, 2, 3, 4, 5. 5 terms. Okay. Now, the number of terms has a name. So you name expressions according to how many terms it has. So if something has 1 term, it's called a monomial. And this, you may have discussed these terms in the past. And if it has two terms, it's called a binomial. And if it has, yeah, oh, you seeing the pattern?
Yeah.
Trinomial, right? So you will have to memorize these names, right? I like to think of it as a bike. 2 wheels is a bicycle. 3 wheel is a tricycle. The only thing that doesn't work for is a 1 wheel one. We call those unicycles, but monomial, all right? Now, anything more than 3 terms, we just use the general phrase is polynomial, right? And technically, all of these are polynomials. They're just special ones with 1 term, 2 terms, 3 terms, right? So I'll be asking you, hey, can you name this expression for me, right? And you take the best name, right? You say, oh, this one's got 1 term, monomial. This has got 2 terms, binomial. Okay. All right. So let's move on to the right side here. Example 1. Right, let's go down the left column where it says terms and count the terms, then we can name them. So looking at the first expression, how many terms are there? 1. Okay. Second expression, we circle the plus, and then we have 3, right? You guys got this? How many terms are in the third one?
2.
2. We circle this. 1, 2. I agree. Third one, how many terms?
2.
Oh, sorry, fourth one.
1, 2.
To 2. 2. Fourth one here. I miscut, right?
Those are all together?
Okay, fifth one. 1. There's no plus sign, just one thing, 1 term. And finally, last one, how many terms? 1, 2, 3. Okay? So now quickly you just refer to the left side of the page and name these. Monomial, binomial, trinomial, or polynomial. I'll write it up on the board here, but just see if you can name them, right? This I'll be asking you to memorize. Right?
So we just say like,
Yeah, don't give me any nicknames. You can write out the whole name. Don't say mono or bi or tri. Just give me the whole name. Right? So if it's 1 term, it's monomial. Right? 2 terms, binomial. Yeah. And 3 terms is trinomial.
are those A's or is it O's?
Which ones?
Is it binomial or binomial?
No meal. So the first one's an O, second one's an A. Meal. Right? I've got the written text right there. Right?
Oh, okay.
Right? All right. Pretty straightforward. Right? The hardest part is not confusing you with what's coming next. All right? So another thing that we can use to help classify polynomials is something called a degree. And every term has a degree. Now, at the grade 9 level, all I want you to do is be able to figure out what a degree is. But in grade 11 is, if you know what the degree is, you can visualize what the graph is. For the of the polynomial, you can figure out how many solutions there are, because eventually you'll be solving these things. Does it have 1 answer? Does it have 2 answers? Has it 3 answers? So degree is just numbers. So if I'm just mentioning it now because you're going to see it in the future. If something has a degree 1, I know in my head it's a line. It might be going like this, it may be going like this, but it's a line. If it has a degree 2, the graph is going to look like this, right? Like this or upside down. If it's degree 3, it goes like this, right? Or it might be a mirror image of it, right? So just eventually you get to learn how you can roughly sketch it, and you can figure out how many solutions our equation has, right? Just by knowing the degree. So you can help doing estimates. Okay. So the question is, how do we find degrees? So we find it by adding the exponents on the variable. That's how you tell what a degree is. Find the degree of a thing. It's by adding the exponents on the variable. Right? So just I'm going to scroll a little bit to the right here, to this box right here. I have 3x. Yes, Izzy? Yeah. So the x has an imaginary 1 here as exponent. So this has a degree of 1. How about the next one? What would the degree of the next one be? No. 3. So we add up all the exponents on the term. So we have a 2 here and a 1 here. That makes a degree of 3. How about the last one?
0.
I had 1, and what did Harmon say through Jan?
0.
0. Yeah, and Harmon is correct. Because we're looking at the exponent of the variable. There is no variable here, right? So this is 0, right? Okay. So to make life a little bit more difficult is a polynomial is made of a bunch of terms, right? So the degree of a polynomial is the highest degree of the terms that exist inside of it, right? So what you do is you go, hey, I got my expression here, and I want to find out what degree this expression is. Well, how many terms does this expression have? No? 1, 2, 3 terms, remember? Separated by the plus and minus sign. Right? So this is where things start getting a little confusing, because not that each individual thing is hard. So there's lots of little definitions. So now we go, hey, looking at each one of these terms, question? No. Looking at each one of these terms, what is the degree of each of these terms? So the first term, what's the degree of this? 2. What's the degree of this one?
1.
1.
So if it doesn't have anything, it's 1.
If the variable doesn't have an exponent shown, that means a 1 from the first unit. Remember that? Right? How about this one? 0. So the degree, these are the degrees of the terms. The degree of the polynomial is the biggest degree that you see. So which is the biggest number you see? 2. Right? So the biggest degree we wrote down was 2. So that is the degree of the polynomial. Okay. So let's do some more practice. All right. What's the degree? We only have one term here. What's the degree of this polynomial? 2. It's the same as the term. Okay, now we have, how many terms do we see here? We have 1, 2, 3 terms. We write down the degree of each one. What's the degree of the first one? No.
1.
1.
It's variable.
4.
What's the one of this one?
2.
2. What's this one? 1. What's the biggest degree we wrote down?
2.
So that's the degree of the polynomial. Okay. Next one.
1.
Highlight the terms. This first one is a 1. What's the second term? 0. What's the biggest degree we mentioned? That's the degree of the polynomial. Okay. Let's switch colors here. First term. What's the degree?
2.
Second term. What's the degree?
2.
Okay. X has a 1. Y has a 1. You add those up. 1 plus 1 is 2.
How do we know X and Y are 1?
Because if you don't see 1,
All
it
these
means
numbers are 1?
In this case, yeah. So what's the degree of this term? The polynomial? 2, right? Okay, next one.
One.
Yeah. And there's only one thing, so the polynomial has a degree of 1.
2.
Okay, first term is 2. Second term is what?
2.
Nope. 1. 0. So what's the degree of the polynomial? The biggest degree we wrote down. All right. So the hardest part of this is just keeping these sorted in your head. All right. It's all adding and counting. It's not that difficult. Okay. Before we still got something to do on the first page here. Before we flip the page over. Harmon. Thank you. Okay. Now, these expressions can also be written using symbols. Right? And depending on your teacher that you have next to you or the resources you're using, textbook and stuff, sometimes they do questions with symbols. Right? So you need to be able to translate an equation to a symbol. So if I say this polynomial here is represented using these blocks here, could you compare this to this and tell me what each one of these shapes means? Izzy?
The black one is negative, or like one positive, one's negative.
Okay. One's positive, one's negative. Okay. So you have different shades. All right. And Izzy says black was positive. Do you guys agree or disagree? I see you shaking the head. Okay. Before we explain why, let's go through what does each symbol represent. Yes, Kaden.
The big black squares are something squared.
Something squared, right? So these are big squares.
Yeah.
So we call them x squares. And here, you guys ready? Right? Right? If you notice, in our expression, we had 2 of them. So we draw down 2 boxes, right? What could those rectangles represent? The 4x. Yes.
Negative 4, but there is only one exponent to it.
Yeah.
That's an exponent of 1.
Exponent of 1, so there's 4 of them. There's representing 4 of these. What are these? Are just x's. So x, 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 x. And we know that they're negative. All right? Because it's supposed to be negative here. Right? And that's how Izzy and Kaden were able to figure out that black was positive and white was negative. Right? If you notice, this is a positive 2x squared, and they're black in shade. Okay? So what do the 3 small little boxes represent?
Just like a single whole number.
Single whole number. We have 1, 1, 1. We have 3 of these, and that's where the 3 from here comes from. Okay? So, lucky for you guys, if we're doing a quiz, we're doing a test, you don't have to memorize what these shapes mean. I will give it to you. So on the back side, here you got a little legend, right? If we do anything with these boxes, I will give you these shapes. So you don't have to memorize them. I'll tell you that these shapes are there. All right? So my question to you, the last question, or second to last question we're going to do today is, hey, we have these symbols representing expressions. Use this legend over here to tell me what expression do we have. So let's just do the first one together here. 3a. What does this represent? Yes, Izzy. x3?
X plus.
All right. So
Ne-
So the rectangle represents x's. That's right.
It'd be negative 1.
But it'd be, but is black positive or negative? Sorry, white positive or negative?
Negative.
So it'd be a negative here. All right. What do the small boxes represent? Going to the legend. Positive 1, 1, 1, 1. How many do we have? 3. Positive 3. So our expression is negative x plus 3. All right? Think you can do the rest, or do you want to do it together?
You hope plus one.
Help you? Okay. I wonder, me and you, this one, next one. The big square, what does that represent?
2x2.
X squared. All right?
Okay.
X squared is how we pronounce it. All right. So, what does the rectangle, black rectangle, represent?
X.
X. All right? What do the small white squares represent?
-2.
Yeah, negative 2. We have 2 ones, right? So then we write it up. X squared plus x minus 2.
How do you know if it's minus?
If it's white.
Oh, so it
Yeah.
just automatically makes it.
Yeah.
Oh, okay.
Okay. All right, Hannah, me and you, next one. Big squares. What are those?
They're negative x2 with exponent 2.
So these are negative x squared. So we have 2 of them all together. So that makes
2x.
negative 2x
Oh, sorry.
squared.
Yeah.
All right. All right, Hannah, what do the rectangles represent?
Negative. There's like
Negative,
x.
negative x. And how many do we have of those?
3.
So this would be
Yeah.
3,
-3x.
negative 3x. All right, last one.
And then there's 4 positive x.
Not x's.
There's no x.
What do the small squares represent?
Oh, it's just a tile.
Yeah,
So
just
it'd be 4.
whole number, just 4.
Okay.
Right? So then we put each individual piece together. We have negative 2x squared, negative minus 3x plus 4. Okay?
So if there's a negative going into something, it's always minus?
Yeah, a negative number is the same thing as saying adding a negative or subtracting. It means the same thing, right? Right? Like you could have on this one rewrote this as plus minus negative 3x plus 4x. Then you're having double symbols. And you have to clean it up. It would end up being this anyways,
Yeah.
right? So you skip that one step. Okay. Last one, Harmon.
Yep.
Me and you.
2x squared.
2. So these are 2x squared. Okay.
2x squared.
Yeah.
Plus negative.
Oh yeah.
Negative 4x.
Count. Double check them.
5x. Negative 5x.
Negative 5x. Do you agree with Harmon?
No.
What did he do wrong?
X. No X.
There's no x.
No x.
The small ones are just whole numbers, right? So
Good enough.
then when you're writing it out, 2x squared minus 5. Okay. Now on your assignment, there's some vocab that might cause you some difficulty if you don't remember it. So I'm going to mention some vocab here first. Shh. So just on the side here, let's just write out some vocab here. If I say, I'm gonna use this as my example, negative 2x squared minus 3x plus 4. If I use the word constant, what does the word constant mean? It means consistency. A number that doesn't change. So in an expression, this is a number without a variable. Okay? So in the expression right above it that I wrote down, what would the constant be?
4.
Yeah. Constant is 4. Okay. Now, if I use the word coefficient, you guys remember that from the first chapter? What does coefficient mean?
Working together.
Yeah, in the exponent unit, we use the word coefficient.
I don't remember.
All right. So we had powers, we had exponents, we had coefficients, and coefficient was the number in front of the variable. All right. So number in front of the variable. So in this above example, what is the coefficient? Or there might be multiple coefficients.
2 and 3?
Yeah, well, close. -2
Oh,
and
negative
-3, right? So include the sign in front of it. That's the thing. -2 and -3. So the coefficients are -2 and -3. Okay?